Hello YouTube, welcome to another multi-cluster discussion. And today's demo is going to specifically focus around ingressing traffic or getting traffic into a multi-cluster OpenShift environment. And so in my environment, I have two clusters sitting in front of F5 Big IP. And so the goal here is to be able to scale out multiple OpenShift clusters. There might be many reasons why you want to scale out multiple clusters. So for example, in this instance, I built a new OpenShift cluster instead of upgrading the existing cluster. And I want to distribute my applications across the two clusters, potentially before I decide I want to settle on 4.13 or potentially move off OpenShift 4.11. So maybe what I do is I move off OpenShift 4.11 onto OpenShift 4.13, and then instead of maybe upgrading 4.11, maybe I just build a new cluster and have two clusters of 4.13. There could be many reasons why you would want to do this. But in my instance here, I have two OpenShift clusters front-ended by F5 Big IP. Big IP is steering or ingressing all traffic to nginx-ingress controller. So all HTTP routing within the cluster is handled by nginx. This is a two-tier architecture. This scales and works really well. It scales and works really well because the developer or the development persona can go ahead and manipulate and create any type of HTTP routing that they want to do. They can use CRDs, OpenShift routes, they can use ingress class, etc., within the nginx environment, within OpenShift, of course. And when applications or pods come up and down, it really only is watched by the nginx-ingress controller. Big IP in this instance doesn't necessarily really care what's going on with all the application pods. Big IP CIS is only watching the nginx-ingress controllers and its replicas. In this case here, I'm using the operator, and I've asked the operator to create 3 replicas. So in this instance right here, Big IP is forwarding traffic to those 3 replicas based on the application. And it can forward traffic to any one of these replicas in any one of the 2 clusters based on application availability. And that's really the beautiful thing here, is that it can go to either 4.11 or 4.13 cluster. And so what CIS is doing here is CIS is orchestrating Big IP with the nginx-ingress controllers IP addresses. And so it's Big IP directly to pod IP, and those pod IPs are of the nginx-ingress controller. So let's talk about how we do that. Well, the first thing is that what CIS does is detects the network and will plumb or configure Big IP with the network characteristics. So that means that Big IP will actually see the pod IP addresses, all of the pod IP addresses within all of the OpenShift clusters. And how that works is that basically CIS is able to pull the information from ovn-kubernetes through pulling the node IP, and the node IP will provide the pod IP, and CIS will configure that on Big IP as routes. In this environment here, we're using ovn-kubernetes. There is no overlays outside the cluster. It is 100% routing from Big IP to the pod via the node. Once it gets to the node, it encapsulates in Geneve based on ovn-kubernetes. That's all handled by the node. There's no kube proxy here involved in the data path. So if you look at CIS, CIS will propagate all of the routes. So let's take a look at Big IP. We're going to the OpenShift tenant, and if we go down to the network and go down to the routes, we can actually see all of these routes. Now, these routes are dynamically created by CIS. If a node gets removed, the routing table will be updated. You're going to have a route for every single node because that node manages a pod subnet. So you can see right here, here are my nodes. I'm sitting with, what's that? That's about 12 nodes altogether, I believe. I think there's 6 nodes per cluster. So if I go ahead and open it up, yep, I'm sitting with 12 nodes. So if I actually bring up my cluster, you can actually see in the OpenShift cluster, if I actually go to the nodes and the node information, you can actually see that in this cluster here, there's actually 6 nodes. And this is of a 413 cluster. If I go to the 411 cluster, it's the same. It's basically 6 nodes. And so what what CIS is doing is it's propagating. You can actually see the masters, the workers, and then you can define where you want to run those pods, right? So those pods will be running on the worker nodes, but CIS will propagate the pod networks. You can see right here 130, 128, 129, 131, 128, and then this is the new cluster 141. You can see here 141 all the way to 150. So the much higher numbers are in the new cluster. That's just really the way that I built that second cluster. When I built the second cluster, I started with CIDR 148. And so that's the setting that I did when I deployed OVN-Kubernetes. So the two networks have to be different from a CIDR perspective, and that's the only thing that you have to worry about. So 148, 149, 50, etc. So this is the first cluster. This is the second cluster. And there's only one instance of CIS in this specific deployment. So in this deployment right here, I've kept it really, really, really simple. I've deployed one CIS instance in the 411 cluster. CIS is using kubeclient to be able to connect to 413 and to pull the information. It's very simple. The information on how to set up kubeclient for CIS is in the configuration here. So if you want, you can run active and then another CIS as standby, or if you want, you can run active CIS and another active CIS. It really just depends upon how you want to deploy this. But only one CIS will update BigIP based on the common API. And so it just really depends upon if you want to take down this entire cluster, but still want a CIS to be basically learn or manage other clusters, then you could run active standby, and CIS has a keep alive, which would be able to detect the difference between the high availability. So more of that will come in another demo when I set up active standby or active CISs. But in today's, I'm just going to do a standalone deployment using cluster IP. So we talked a little bit about CIS using kubeclient. So for CIS to use kubeclient, CIS has to have the secrets for the OpenShift 413 cluster. And how we do that is just simply copy over. So you can see right here, what I've done is I just copied over the kube config for the OpenShift 413, and I went and created a secret. So create a secret called OpenShift 413 from the following file. So you just copy the kube config over. From the kube config, you create a secret, and you can actually see here, I have OC get secrets, I have the 2. So within 411, it has its own, so you don't have to worry about it, and you only need the 413. 413 does not need the 411 because there's no CIS running there. One thing that you have to do in the remote cluster is configure the RBAC in the remote cluster for CIS, so it's able to access the informers. That is pretty much it. I mean, that's all you have to worry about. CIS is going to take care of everything. So CIS is ultimately going to subscribe to all the informers that you ask it to watch. And I'll show you when I create the route in a second. So if we go back and look at BigIP, if I go look at the public IP on BigIP for OpenShift cluster, I have no public IP address. So going back to that diagram right here, there is an OpenShift route here, but the OpenShift route hasn't been deployed. BigIP has no public IP address to ingress traffic to the nginx-ingress controller. And a single route should have 6 nginx-ingress controllers. So let's go and take a look at these controllers. So if we go to you can see there's no route. This is the 411 cluster. But if we go to the installed operator, you can see in this cluster, you can see that there's the nginx operator, and this nginx operator has a substantiated instance. That's the name of it. And in this instance here, I've deployed 3 instances. And so if I go look at the workload and look at the deployment, you can see that there are 3 pods in each cluster of the nginx instances. I can actually see the pods right here. And if I see these pods, I can actually see their IP address. So this is the IP address of the pod itself. So this is the address that will be populated, or the addresses that will be populated in the big IP. It's big IP, virtual IP, direct to pod using ovn-kubernetes. And so big IP will just send the traffic to the node IP of that subnet. So 128.2, that's where that lives. If I look at the routing table, you can see from the routing table perspective, OpenShift routes 128.128 network right here. All traffic for this network will go to one of these nodes. 128.2, here it is. It'll go to this worker node, which is 10.192.125.177. That's a worker node. That's basically a virtual machine that's running in my ESX cluster. So that's kind of how that works. That's where that pod lives. That pod that you see right here, that pod lives on that worker node, and the traffic, big IP, will route to that destination through this node. This is how ovn-kubernetes works. Ovn-kubernetes is not extended, or Geneva is not extended outside the cluster. We don't need to make it any more complicated. This is the simplest way of doing it. So from a big IP administrator, CIS will create the routes. The big IP administrator has to do nothing. The only thing that you would need to do on CIS is enable 2 configurations. So let's take a look at what those 2 configurations are. If we want to deploy our CIS, let's take a look at what the 2 configurations on CIS would look like. And so I'm going to go and open the CIS deployment. And it's actually pretty trivial. There's really not much that we have to do on CIS here. And so for CIS, the first thing is I want you to operate in mode controller. I want you to run as a multi-cluster mode standalone. I want you to manage the static routes and orchestrate for ovn-kubernetes. It's really just those 2 specific configurations that I want to do. CIS will take care of all of the automation for you. We've really simplified this. I've been working very hard with product management within Red Hat to simplify and remove any hybrid approach, any external overlays using something like Flannel, which is a VXLAN approach. This is very similar to Calico, but you're not using the Calico CNI. We're using the ovn-kubernetes CNI, which is default now in 4.12 and beyond. It's kind of like the recommended approach. So simplify, let CIS basically handle. You can see CIS is handling the following 3 namespaces. So I'm pruning CIS to only watch certain namespaces, and namespaces that you've configured for potentially. Maybe you want CIS to watch other applications as well. You can do that. Maybe all HTTPS traffic is coming into nginx, and maybe all TCP traffic for like Postgres or databases, TCP traffic is handled on a different namespace. So I know there's a lot here, and there's a lot to go around, but this demo is just a little intro into this, because this can get a little complex. But we can always set up a call to kind of go through a little bit more detail with the networking and Red Hat folks. So getting back to this diagram, so we've deployed CIS. We can see CIS is running. If I go to the OpenShift cluster, if I go to the pods, change this to kube system, we'll see that there's my CIS instance that's running. And so I've deployed CIS in 4.11 cluster. I've deployed the role-based authentication in the 4.13 cluster. In 4.11 cluster, I have both of the kube config secrets. So so CIS can pull the informers for the services that it's subscribed to. And so now what I'm doing, I'm ready to actually go ahead and create a route. So before I create a route, go ahead and deploy your nginx-ingress controllers. I'm not going to go into this. There's lots of really good videos I created, the link that you need. It's very, very, very simple. One thing I did do by default, it's node port. I changed the service to be of type cluster IP, right? So I did make the change to be of cluster IP, and I incremented it based on 3 replicas. You can decide how you want to do that. Everything is managed through the operator within OpenShift. It's really smooth. If you want a demo on how to do that, I can create a demo on how to deploy the nginx-ingress controller within OpenShift. And so I have to deploy both the nginx-ingress controller both on 4.11 and 4.13 because this is the application stack. And then, of course, I also have to deploy both of my applications on both clusters because at the end of the day, the applications are the same. They're kind of unique. If you don't want them to be unique, then you can create specific configurations, and I'll show you how to do that. So how do you differentiate a configuration? You differentiate everything within the OpenShift route. So let's go and take a look at the OpenShift route that I have configured. So let's go ahead and open this in a new tab. And so here's the OpenShift route. This is where the magic is. And so currently right here, we're still using OpenShift routes. We will move to potentially Gateway API in 2024, maybe 2025. We're basically we're waiting for Gateway API to mature. But this concept is very similar. The concept here is the route is only created for on Big IP Gateway. It's only created for Nginx Ingress controller. Nginx Ingress controller is managing all of its HTTP routing through a separate function. It could be routes, it could be on many different namespaces. But in this instance here, we're using the nginx-ingress namespace to manage everything for cafe.example.com. So anything for cafe.example.com would be sent to the nginx-ingress controller pods, and it will be distributed between the 2 clusters. And you can see we created this new annotation for multi-cluster services, so you can see this is the cluster name. I'm telling CIS to monitor both clusters, so cluster 4.11 and cluster 4.13, based on the service name right there, the namespace, and the port. That is all that you have to do to be able to configure the multi-cluster for this route. So we've integrated multi-cluster into the route. It's the cleanest way of doing this from all the research that we've done over the last 6 to 8 months, and we spoke to quite a few customers. If you're one of those customers we spoke to, thank you so much for your awesome feedback. So we also do have quite a few benchmark customers, and we actually do have customers testing this worldwide, both Kubernetes and OpenShift. So you might ask me, well, Mark, where do I get the public? Where do I set the public IP? How am I administrating the gateway? Now, in Gateway API, the gateway CRD or the gateway configuration is separate from the HTTP routing. And that's the goal here. It's to separate the global configuration from the route configuration for the pod itself. In our instance, it's Nginx pod. It can be any pod, but we really want to focus on Nginx pod. So looking at CIS, you can see before it used to be one public IP per CIS instance. We've moved away from a single public IP for an OpenShift router. So we used to be an OpenShift router. We used to have a single public IP. That's no longer the case. This IP right here is of the big IP itself. So we're managing the public IP very similar to how we would manage it in Gateway API. And so to do that, we're using something called a global config map. So think of a global config map as your gateway configuration to manage your gateway. This manages the big IP to steer traffic to the clusters for a specific namespace as well as a specific public IP. So let's take a look at the global config. And so the global config is using a config map. Why are we using a config map? Super stable. Been around for a while. It's YAML based. And so this is what we wanted to do for our global config. So global config is all, think of it as global big IP configuration. It could be any specific set of global configuration that is required on a big IP virtual, from login to security to edge services to TCP, HTTP manipulation to public IPs, etc. All of our high availability for CIS is configured under the extended spec. So you can see high availability for CIS. This is a primary cluster, and I don't have any HA here. So I don't have a secondary cluster for CIS. So I've only specified the primary cluster. In this case, I'm also not doing the keep alive, but I could keep alive it if I wanted to. Check the docs for more of that. You'll see here is my external cluster. There's my external cluster. It's a 411 cluster, and this is where the secret is. This is very, very, very simple. We've really thought about this a lot to simplify it. Here is my extended route spec. This is something that we started probably about 18 months ago to define something called next-gen routes. And what next-gen routes are is it allows CIS to create and manage multiple routes based on multiple public IPs within one CIS controller. And so thank you everybody for all of the feedback, the hard work, the testing that has come into this. So you can see here I've got two namespaces, Cafe 1, which is one set of applications. It has this following public IP, and that is one set of, if you want to call it, configuration. And I can add a lot more configuration here, but I wanted to kind of keep this example simple. In my example here, I'm using namespace nginx. This is my public IP. This is my virtual server name, right? So right here. So this is kind of how we define it. So all I need to do is go ahead and create the route for those nginx instances. And this is where it will pick up the IP address, the name. If I wanted to do any type of like TCP manipulation, I could do proxy protocol. I could add that here with an IRUL. I would just reference the IRUL. It would be existing on big IP. And ultimately, what CIS does is basically takes this config file, it takes the JSON, merges together, and sends it to big IP with a common API. And so this is the global configuration where I configure all of my big IP gateway information. And then here is the OpenShift route that I create to ingress traffic to the nginx-ingress controller. This is just a pod. CIS is just treating nginx-ingress controller as a pod. It could be any pod, doesn't matter what it is. Anything that runs as a service that has a destination endpoint we can use. In this case right here, we want to use nginx because that's the better together story with regards to this architecture and solution. And I think this two-tier architecture does make sense. Gateway to routing to inside the cluster, and then you can do all of the app protection, application protection within nginx, all of the security layer at that point. So let's go ahead and create the route. As you can see within my OpenShift cluster, let's go back to the OpenShift cluster here. This is the 411 cluster. Let's go down to the network. Here is the route. I'm going to create the route through the CLI. So I'm going to do OC create, and we'll do a -F, and there, let's see where we are right here. There we go, ls, so there's my route. So OC create, -F, and that is a nginx route on 443. So we'll go ahead and create that route, and we see what cluster is this? This is the, let's see what cluster I'm in here. This is the 411 cluster. Okay, let me go down to the route, and where is my route? Change the namespace to nginx. There we go. Almost caught me. That's so important to actually break down the namespace. So you can see there's the route right there. Let's go ahead and take a look at big IP, and you can see here are the two routes on big IP. There is that public IP address .66.10.192.125.66. You can see that IP is right there. That's where it's coming from. It's coming from the global configuration with the route of nginx-ingress VS. That's the route name. So if I go back, there is the name, and of course there's a port 443 and a port 80. Let's go look at the pool member associated to this. If you actually click on this, you'll actually see the configuration. There's actually a pool member that's associated. There's no security in this case, but I could add security if I wanted to. But let's go look at the pool member. Aha, so here's our pool members. There's our pool members. So you can see 1, 2, 3, there's 6 pool members. So remember I talked about 10.128.2.84, that right there, if I go back into OpenShift and go back to the deployments and go into this first one and let's go into the pods, my mistake, and go into this first pod right here and get its IP address. There we go. So 10.128.2.84, that address right there matches up with that one. So you can kind of see that what CIS has done is it's pulled both clusters. Let's take a look at the second cluster. So the second cluster is the 413 cluster. And in OpenShift 413, let's go look at the pods. Let's look at the first pod right there. There it is, 148.2.142. And you can see 148.2.142. That's the second cluster. So CIS here really just sees endpoints. It sees IP addresses, downstream servers. It's kind of what it sees. It sees them in 2 different clusters. Big IP doesn't really know that there's 2 clusters there. It doesn't really matter. It's just going to route. So to get to this 148.2 network, it's going to use its routing table, and it's going to go ahead and send that traffic 148.2, which is down here. 148. It has been added, and so 148.2 will run on this device right here. It's running on this. I believe that's correct. 148, and that's what OpenShift put it. OpenShift put it on this device right here for worker. So I could go back and look to make sure. But yeah, that's where that went based on that network. It's doing some network stuff there. 148, yeah. So that's kind of how that worked in that environment. And so let's go ahead and establish some traffic to that route. So we can go back to the route. We can select traffic. There's the nginx-ingress controller. Nginx-ingress controller is going to route based on a path, and you can see it right here. You can see that is the actual IP address of the backend application. There is the IP address of the nginx-ingress controller, and that is the IP address of my client. Right, my client's coming through. So you can kind of see right there. I can actually see the physical client. No, this is the IP address of the big IP 62. That's the default gateway. There is and then that right there is the backend server, the backend service that's running on there. There's a service that's running behind the nginx-ingress controller. So that's this environment. Let's go back and review based on the architecture and document. So what's really cool about this is that I am doing OpenShift ingress in a true multi-cluster fashion. So I'm introducing and providing visibility into OpenShift using multi-cluster. And so that's what this demo demonstrates. So hopefully this is useful. If you would like to test this, let me know. This code is public. It will be released early September for general availability, so it will be on our GitHub page. It is fully supported, so you can go ahead and play, test. We would make improvements on it. If there's any issues that you find, we'll definitely fix it. But this is the concept of kind of what we're doing. This is the introduction of working in a true multi-cluster environment, which solves a lot of problems. Please like and subscribe to this video if you're not subscribed, and let me know what other demos you would like to see, or if you have any questions, just go ahead and post them in the comments. Thank you very much, and have a lovely day.